Hello, this video is going to be on IXL Algebra 2 topic L2, roots of rational numbers. So we're going to find the real number roots of the square root of 1 divided by 25. When we're finding the root of this, you can think of it as finding the square root of 1, and then on bottom, the square root of 25. Now, since both of these are perfect squares, what is the square root of 1? Well, 1 times 1 is 1. And what's the square root of 25? 5 times 5 is 25. So the root of the square root of 1 over 25 is 1 over 5, or 1 divided by 5. Now, you'll notice if you take 1/5 and you multiply it by itself, remember when we multiply fractions, you just multiply straight across on top, straight across on the bottom. 1 times 1 is 1. 5 times 5 is 25. So when you're doing this, you'll notice how 1/5 times itself is equal to 1/25, which is what the question was asking us. So the real number root, the square root of 1/25 is equal to 1/5. 1, 5 in the denominator. This one's very similar because both the numerator and the denominator are perfect squares. So what times itself is 25? 5. And what times itself is 4? 2. I'll skip ahead so that you can see what we do when the problems get a little bit more difficult. 49 and 100 are both perfect squares. So this is 7 over 10. All right, let's look at this one here. So here, the index is a 5. So what we want to do is we're finding the 5th root. So what times itself 5 times makes 32? Well, remember when you multiply something by itself 5 times, it grows very quickly. So on top, we're finding the, let me write this down here so there's a little more space. On top, we're finding the 5th root of 32. And then on bottom, we're finding the 5th root of 243. Now, if you already did the last topic, L1, we have had both of these problems likely by now. And you should know that then what number do you multiply by itself 5 times to make 32? That would be 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. What number do we multiply by itself 5 times to make 243? Well, that number would be 3. And we can check it by doing 3 times itself 5 times. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And 81 times 3 is 243. So this is really just 2/3. If you multiply it by itself 5 times, you'll get 32 on top and 243 in the denominator. 2/3. All right, these are pretty similar. I'm going to keep going. Here you're finding the 4th root of 1 over 256. Let's go ahead and try this one together. So what's the 4th root of 1? Well, any root of 1 is just 1 because 1 times itself any number of times will still be 1. And then what's the 4th root of 256? Now we know this number is going to be greater than 2 and greater than 3 because we just had the 5th root of 243 and that was 3. So what number would you multiply by itself? 4 times to make 256? Well, since this is even, let's try 4 and let's see if it works. 4 times itself 4 times, because we're looking for the 4th root. That would be 16. 16 times 4 is 64. And 64 times 4 is 256. So the fourth root of 256 is 4. So this equals, remember the fourth root of 1 is just 1. So this is 1 over 4. So the numerator is a 1, the denominator is a 4. All right, this one's very similar. If you multiply this one more time, but here we have a negative number, right? So since there's a negative here, you have to make sure to include it, because since we're taking the fifth root and the index is odd, when you multiply a negative times itself 5 times, notice a negative times a negative is a positive. A negative times a negative is a positive, but there's still going to be a negative left over, right? So we need to make sure that we write a negative in our answer, right? And then you just do the same process. 1 times itself 5 times is 1, and then 4 times itself 5 times would be 1024. Because if you'll notice, we multiply this by 1 more 4, 256 times 4, that's 1024. Those are some really good numbers to know. If you think about 2 and then keep doubling it, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Up until here, those numbers come up very often because they follow the base 2 exponential pattern. All right, let's keep going. Let's see if we have any new concepts. All right, here's a good one for us to do. So this one's pretty interesting. I think the best way to approach this one when it has a decimal is to first make it into a fraction, okay? So let's think about what is the sixth root of, well, let's make this into a fraction. So this is 64 on top. And then on bottom, what I want you to do is count the decimal points, okay? So this is 1, 2, 3, 4, 5, 6 zeros, right? 1, 2, 3, 4, 5, 6 zeros. So we want to know what's the sixth root of, let's see, this is thousands, millions, of the sixth root of 1 million. So let's think, what times itself 6 times equals 64? Well, that's a pretty small number for doing 6 times. Let's try 2. 2 times 2 is 4. Let's count. 2 times 2, that's 2, is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Times 2 would be 64. So 2 to the 6th power is 64. And then let's think about this. What would we multiply by itself 6 times to get 1 million? Well, look how many zeros there are. 1, 2, 3, 4, 5, 6. So since there's 6 zeros, that would be 10 to the 6th power. 10 times itself 6 times, we just keep adding zeros, and you'll have 6 of them once you're done. So our answer is 2 over 10, or 2/10. So let's go ahead and put it says, simplify your answer and write it as a decimal. All right, so let's go ahead and write this as a decimal. How would we write 2/10 as a decimal? Well, this would be 0.2. 0.2. All right, this is very similar. You just have to have a negative sign. Let's try one more of these. So let's go ahead and find the third root, or the cube root of -1 on top. And on bottom, we have the cube root of, remember, let's count the decimal points. 1, 2, 3, 4, 5, 6 zeros. So again, that's going to be 1 million. 1, 2, 3, 4, 5, 6 zeros. All right, so we're looking for what number times itself 3 times makes -1. Well, that's -1, because if you multiply it by itself 3 times, the negatives will cancel, but then there's still one negative left over. And on bottom, what number would you multiply by itself 3 times in order to make 1 million? Well, there's 6 zeros, right? So each time there must be 2 zeros. If you do 100 times 100 times 100, that's the same number multiplied by itself 3 times. That's how you get 1 million, right? So what we have on bottom, the cube root of 1 million, is 100. Now let's make this into a decimal. Let's remember to keep it negative. Since it's a decimal, we'll start with 0 points, since this is less than 1. And this is a negative 1/100th, not negative 1/10th. So we have to put a 0 in the tens place and a 1 in the hundredths place. So if you want to write this as a decimal, right, 1/100th, think of it as 1 cent, right? Let's go ahead and remember to put our negative sign, 0.01. All right, let's see if the challenge zone is any different. All right, so let's do one of these also. So this challenge question, even though once you get to 90, you have the A, you might want to get to 100. A lot of you have been getting to 100 because you like the challenge of it. So how many real square roots does negative 121 over or divided by 141 have? So when you think about this, what you want to realize is a square root, right? A square root, when you have a negative 121 divided by 144, how many square roots does this have? Well, how would you make this, how many real square roots, right? When you have a negative number under here and you're taking the square root, there's an invisible 2 here, you have to multiply some number by itself twice, and it has to end up with a negative. Now, there is no real number that you can multiply by itself and turns out negative. It always turns positive, because a negative times a negative is positive, and a positive times a positive is positive, right? So either way, this number will be positive. So since there is no way to make a negative number with a square root, it has 0 real square roots. All right, what about 0? The square root of 0. When you take the square root of 0, well, is 0 positive or negative? Well, it's kind of neither, right? It's not positive, but it's also not negative because it represents nothing. So if you think about it, the square root of 0 is 0, right? 0 times itself is 0. But there's no other way to write that. Negative 0 is the same as positive 0, right? So there's no difference between these things. This is just one solution. This is just one number, right? It's the same number. Negative 0 and positive 0 are the same. So how many real square roots does 0 have? Well, it only has 1. All right, and then how many fifth roots does 1 over or 1 divided by 243 have? Let's go ahead and write this out. A fifth root. So this would look like the fifth root of 1 divided by 243. Okay. Now in this case, the 5 is odd, right? The index is odd. Not like when we had a square root and the index was even. So what could we multiply by itself this many times, 5 times, in order to make this? Well, you could do 1 over 3. And then let's check if you could do negative 1 over 3. All right, sorry, that's a 3. So if you did 1/3 to the 5th power, we're going backwards to check it, you would get 1 divided by 243. So that would be one solution. Now let's try the negative 1. If you multiplied it by itself 5 times, let's see, the negatives would cancel out, but then there would be 1 left over because this index is odd. That would make it negative 1 over 243, which would not satisfy the radicand. It would not be this number, right? So since this is odd, right, the index is odd, 5th, And because this radicand, what's inside, is positive, when you have an odd index and a positive number that you're taking, you only have one solution. This solution right here, right? This one works. This one does not because of the negative. All right. Hopefully this helps. And once you get to the 90, you can always stop there. But if you can get to 100, that really shows me that you understand the topic very well and you've mastered it, even at a higher level. Good luck.